Welcome to EDU World Space.
In this problem, we're being asked to look at CO2, carbon dioxide, decomposing into its elements, right? So what is the ratio of the mass of oxygen to carbon? Well, we just take the mass of oxygen, 0.727 grams, and put it over the mass of carbon. We can simplify. We get 2.66 grams of oxygen for every 1 gram of carbon. Now, that was part A. In part B, we're being asked to consider a different sample, one that has 0.571 grams of oxygen over 0.429 grams of carbon. And so now we get a different ratio, 1.33 grams of oxygen for every 1 gram of carbon. So this should already lead us to think that, well, if the ratio of the atoms is not the same, or the masses of the atoms is not the same, then, according to Dalton, this second compound is going to have a different empirical formula than the first. And so what we need for this is to consider molar mass, okay? So if we go back to the first compound, right, we know just from looking at CO2 that for every 1 mole of carbon, there are 2 moles of oxygen. That's what we need to figure out for problem B, right? So we're going to take our ratio, 1.33 grams of oxygen, set up our dimensional analysis. 16 grams of oxygen for every 1 mole of oxygen gives us, let's set up actually our second so 14 grams of carbon, actually 12 grams of carbon for every 1 mole of carbon. So if we solve that, do the math on that, moles of oxygen, moles of carbon, and actually if we look at it, it seems like these are pretty much in a 1-to-1 ratio. And so we can think, well, this will correspond to carbon monoxide, CO.